Hey there, in today's video I would like to talk about the new and delete operators of CODESYS and what's their purpose. So let me start with the new operator. The new operator allocates memory on the heap. That means that we are using dynamic memory allocation and we are reserving memory for function blocks or arrays of standard data types. With the delete, we are releasing this memory that we have allocated with the new. So basically, with the new operator, we can create dynamic arrays and function blocks in runtime. To use the new and delete operators, you should first go to Application, Properties, Application Build Options, and check the checkbox Use Dynamic Memory Allocation. This will allow you to allocate the memory that you need. In my case, I have entered 2000 bytes just to show you some exceptions. Let's say I want to allocate strings. That means that one standard string has 81 bytes. That means if I allocate an array with 10 elements, I'm gonna reserve 810 bytes. Pretty simple math. So that was the first thing you should do if you want to allocate some memory. The second part is you have to have a pointer to the data type that you want to allocate. If I want to allocate an array from strings, I have to have a pointer to the data type string. If I want to allocate, let's say, a function block, here I have one function block dummy. The function block doesn't do anything, just it has an input and output, and just the output is equal to the input. But if we want to allocate a function block, we need this pragma. So enable dynamic creation. That's very important. Else you will not be able to create a dynamic function block. So let me show you first how does normally the new and delete operator works without any errors. I'm gonna log in to my program, and here I have some toggle bits that I'm gonna enable just to allocate my array. As I have showed you, I have a pointer to string. That's my pointer to string. And the new operator is returning a pointer. That means the new operator needs exactly two parameters. The first one is the data type that we are allocating, and the second parameter is the size that we want to allocate. So as you can see, my pointer string points to 0. I can enter 10 elements from type string, and I can just enable the new function. Now, as you can see, because the new operation was successful, my pointer is pointing to some memory on the heap, and this is the start address of my array of strings. Now I can access the array normally in two ways. The first way is the normal way, so just with parentheses you can access every single element of your array. I have already allocated 10 elements, so I can write something to those elements. Let's write something to the first element. Let's say A, and I'm just gonna toggle my bit to write this. I can write something to the, let's say, to the fifth element. Let's say this will be A, B, C, D. And I can write something, let's say, to the last element. let's say here I'm gonna write last, and I'm just gonna execute this. So now I have written those three elements of my array. To show you that those elements are written down, I have created one just a show array which has 10 elements which are now empty, 10 elements of string. That's the array. So to show you that I have written something down, I'm gonna show you this normal for cycle where I'm assigning the pointer, the elements of the pointer, to this mirror array. Let me execute this assignment. Now, as you can see that my array, mirror array, there it is, has exactly the things that I've written down. Probably I forgot to write the fourth element, but we can do this again just to show you that everything is correct. Here I had the D, and I'm gonna execute it. Now I'm gonna assign the elements again one more time, and as you can see the D is already here. Now let's say I'm done with my job with the dynamic array, and I have to release the memory, so I can just delete the memory. Now the dynamic allocated array is deleted, it doesn't exist anymore. As here, if the allocation was okay, we are receiving an address. If the delete operator was successful, our pointer will point to 0 again, or has the address 0 again. So that was the first way how you can access your elements on a dynamically allocated array. Just normal, because the pointer is an array. The second way, I can allocate the memory again. I'm gonna still have the 10 elements, that doesn't really matter. But for this part, I'm just gonna buffer the address of the first element after we allocate the new array. As you can see, that's the starting address from the new allocated array. Now, the second way how we can access the elements of the pointer is by directly with the address. How we can do that? That means we need the starting address plus the size of the data type and multiplied by the element number. Let's say I want to access the fifth element again. I can just execute this function, or I can just execute this algorithm. Now I'm pointing to the fifth element of the array through the address of the pointer. Now I can just write something, let's say hi there, and I can write it with the dereferencing from the with the pointer. Now my fifth element should have hi there, but before we check that, we should return to the starting address of our array. That's why I needed the buffer when I was allocating it. So now let me go to the first address, so the starting address of the pointer. Now, okay, I gave the starting address, and now if I again, well, I want my mirror array. Where is the mirror array? There it is. As you can see, that's the mirror array from the previous time. Now I'm gonna pass again the new elements of my allocated array. And as you can see, we only change high there on the fourth element. So that's the other way how you can access your elements in the dynamic allocated memory. But I will tell you that you should just use the normal way and access the elements of your pointer or your array with parentheses, and not with the address of the pointer. So I can close that. We don't need it. Like this. Okay. Now I have allocated an array again, and I should release it when I'm done with it. And I've done this. It's very important that you delete only the array if it's pointing to the starting address. You should not delete the pointer if it's pointing to some other array address, like I was pointing to the fifth element. You should not delete it then, because you're gonna receive an exception, an error. It is also very important that you never lose the starting address, and you should never allocate another array, or again, you should not allocate the memory if you already have an allocated array. So let me show you that. First, I'm gonna allocate just normal the dynamic array that we have. That's its address. I'm just gonna copy it. So that's first 10 elements. Now, if I don't pay attention, I can allocate another 10 elements. As you can see, we have totally different address. Now, if I delete the pointer like this, I didn't delete the first array as well. I only deleted the second array. That is why now I have a memory leak, because the first array, normally you don't have its address. And that means that now we have lost 810 bytes. To prove that to you, I can write the address to the pointer. And as you can see, the memory is still allocated. So you should never allocate a second time if you already have allocated once. Now I can delete this one, and there is no memory leak. But that's very important. You should only allocate one time. If I, let's say, allocate more than once, so now I have 810 bytes. I didn't notice that. I can try to allocate again. So now I have 1020 bytes. If I try to allocate again, I'm gonna go over my 2000 bytes and I cannot allocate anymore. Now I don't know the old addresses of the allocated areas, so I cannot delete anything, and my heap is full, my memory is full, and that's what we call a memory leak. And I cannot go back to those arrays because I don't know the addresses anymore. That is why you should now reset, clean your solution, and you should just log in again that the heap is now empty, everything is back to normal. But that's what we call a memory leak, and you should never ever do it. Now, if I try to allocate more elements or more bytes that I actually reserved in my application, my pointer is just gonna return 0. So let me show you that. Now I want to allocate 1000 elements. If I put the pointer, I'm gonna receive 0 because the new operator was not able to allocate 1000 elements. That's how you can check if your allocation was successful. Let me type 10 again, and I can show you that we can allocate them, and there they are. So now I have again an array from 10 from 10 elements, and I can delete it. Now, as I said, if you have a function block and you want to allocate it, you should always use the attribute enable dynamic creation. Here I have create one allocation from this function block fbetDummy, and I want to just create one element from fbetDummy. Now I have a pointer from type fbetDummy. Here it is, and I'm just gonna allocate one time in the function block. So now I have my pointer is pointing to memory on the heap. So I have reserved this memory, and I have the fbetDummy, and I can just write some numbers to it and call it. As you can see, my function block doesn't do anything, it's just assigning the input to the output. That's it. But you can see I can do some stuff with my function block, and when I'm done with the function block, it's very important again that we delete it. Again, we are passing the pointer to the delete. And as you can see, the reference is invalid because the pointer doesn't exist anymore. So that's basically what you can do with the new and delete operators from CODESYS. In the previous video, I've showed you one sort and filter function. The filter function needed two arrays. Actually, if you missed that video, I'm gonna put it in the link to it in the description below, so you can go ahead and watch it. But for this function, we needed two arrays from the same size, and those arrays were as an var in out to be passed to the function. Now I can show you how you can use the new and delete to sort the list again. Now we're gonna pass only the source array with all the names of the countries. First, when I execute my function block, I'm gonna check if the pointer is different 0. That means that a memory was already allocated, and I'm gonna return with an error. If not, I'm gonna allocate the string, the new array of strings that will be exactly the same size as the source element. So if the allocation was okay, my pointer should have a different address as 0. If not, I'm gonna return an error that the allocation was not okay. If the allocation was okay, I'm just gonna copy all the elements to my new array from the source array. In the next step, I'm just searching for a specific phrase or a specific word, and if I have found this word, I'm just gonna paste it back to the source array. If I'm not searching anything, so if the searched word is empty, I'm just gonna return the original list. And when I disable the function block, as I said, we should always release the memory. When I disable the function block, I'm just gonna return the original list and delete the dynamically allocated array. That's it. Let's give a try. Let's give it a try. So here's the function block, and I'm passing one array of strings. This array of strings is now empty. This is from the previous video, and I'm just going to fill it with some initial values. Those are names of some countries. I can sort it with my bubble sort, so from biggest to smallest. And when I enable the function block, I can just do that so you can see it. When I enable the function block, we will see that we gonna create a new array. Now, as you can see, everything was successful because my pointer has an address now. That means that I have successfully allocated 10 elements. Now, this is the list, and if I write, let's search for a Y in the array, you can see that the list has now all the words with Y: Egypt, Turkey, Italy, Hungary, Germany, Egypt. If I disable the function block, that means I'm gonna delete. First, I'm gonna pass the list back to the destination array, and I'm gonna delete the dynamically allocated array. So, as you can see, now I have all the original values. I can just enable it again, and let's type something else. A. So Brazil, France, Andorra. If I put false, I'm just gonna delete and return the original array. So guys, that's basically what you can do with the new and delete operators from CODESYS. If you have some questions, please don't hesitate to contact me, and I will try to help you with your project. Thanks guys, have a good one.